into microservices testing, you should know the difference between monolithic architecture and microservices architecture. So we will see the pros and cons of each of the architecture, and then we'll see what is containerization and how containerization applies in microservices testing. So now let's try to understand what is this monolithic architecture. Before microservices architecture, everything was monolithic. What is the meaning of monolithic? It's something big or huge, right? So this monolithic architecture, it's a traditional software architecture wherein all the components or all the services are tightly interconnected. Let's take the example of an e-commerce application. It has three modules: purchase, sales, and in-stock. Purchase module is keeping track of all the items which are purchased. Sales module, it will keep track of all the items which are sold. And then in stock. In stock means you want to know what is the item that are in stock, currently in stock. You have to refer purchase table as well as sales table to get the in stock item, right? So there is some dependency. If you want to get the in stock, you have to refer both purchase table and sales table. So you need to write the query accordingly. So when an application is developed using this monolithic architecture, it is built as a single unit. Single unit in the sense there will be one single code base or there will be one repository wherein all the libraries, configuration files, dependencies will be available in that single code base. When everything is available in a single code base, how we can develop the system? The development will be much easier, right? So when it comes to development is much easier compared to any other architecture. When it comes to testing, everything is in a single unit. So testing can be performed in a much faster way. When it comes to deployment, as it is a single unit, the deployment is much easier and easy debugging. There is a single code base, there is a single repository. So debugging can be performed in a much faster way. So if you look at here, you can see that development time is easier. Then end-to-end testing can be performed in a much faster way, easy debugging. So obviously, what about time to market? This product can be easily deployed to the required environment, right? So this architecture, we can relate to a person who is making tea in a small tea shop. There will be one single unit or one single instance. This person will receive the order, then he will prepare tea or coffee based on the customer choice. He need to clean the utensils and then he need to serve it. Finally, he need to collect the price also or the amount. So here, if you look at the process, you can see that it is highly interconnected. There are dependencies, right? So this example, you can easily relate to a monolithic architecture wherein all the components are tightly interconnected. If monolithic architecture has this much advantages, then why are we thinking about a different architecture? There is a single code base. Every information is available in that single code base itself. So the application can be developed in a much faster way compared to other applications which are of distributed nature. So it can be easily developed. And it is a single unit. Compared to the distributed application, testing can be performed much easier way. If the components are located in different places, you have to devise your own testing strategies. So testing can be also performed in a much faster way. So in our tea shop example, imagine that in morning 10 a.m. to 11 a.m., there is a rush. There is only single person and that person is responsible for doing all the duties or all the tasks. So when there is high traffic or when there is high load, what will happen to that system? It will be definitely affected, right? That single person won't be able to handle the multiple requests. So it will lead to a system failure or degraded performance. So that is the main disadvantage of this monolithic architecture. There is scalability limitation. In this architecture, we cannot scale individual components. If you want to scale one component, it is not possible. You have to scale the entire application. Individual components cannot be scaled. Then another one is reduced development velocity. What does that mean? Monolith, as the more and more features or functionalities are added into this application, it will grow bigger and bigger, right? When it becomes bigger and bigger, what about the complexity? It will increase, right? Complexity will increase. So when complexity increases, what about the development? it will go down, right? The development speed will go down. And another problem is that if there is any error in any of the component, it could affect the entire application's availability. As the components are tightly interconnected, if there is any issue in any of the component, the entire system won't be available. And about the deployment, this is a single unit. So even for the minor changes, you have to redeploy the entire application. You cannot deploy a one single component. Then coming to the framework level changes, it is expensive and time consuming as it is tightly interconnected. And even for the minor changes, we have to perform end-to-end regression testing. After that, only this will be deployed to the corresponding environment. So to overcome the problems with monolithic architecture, microservices architecture came into picture. So in this microservice architecture, the entire application, it is divided into individual microservices. Each microservice is capable of addressing a single business capability. What is a business capability? It is similar to a requirement. Let's take the example of Netflix. So in Netflix, there are different requirements like there should be a provision for the user to search for the videos, and there should be a provision for streaming the video. Based on our choice, we will be able to view the videos and video recommendations. So these are the different capabilities, business capabilities that are available in Netflix. So corresponding to each of these business capability, we will create different microservices. And what this architecture do is that it will take a complex business problem, and that business problem is divided into small components, thereby achieving a perfect solution for that business problem. Here, as much as possible, the dependency between the microservice is reduced. All the microservice is kept as an independent unit. So that is the meaning they are loosely coupled. Each of the microservice, search, streaming video, video recommendation, has its own business logic. The business logic will be written inside APIs, and it has its own set of database. So this is an independent unit. Each unit is capable of functioning on its own. As much as possible, the dependency between microservices is reduced. Another advantage is that each of the microservice can keep its own version. It is not mandatory that every microservice will be in the same version. Let's take the example of an email microservice. What is the function of an email microservice? It's sending and receiving emails, right? So once that microservice is ready, it will keep on functioning in the way it is programmed to do, right? There is, unless there are any requirement changes happening. So that service is ready, it will keep on working. Similarly, in this example, we have three microservices, one for search, another one for streaming video, and another one for video recommendation. So here, assume that in video recommendation business capability, there is a requirement change. So at that time, only this video recommendation microservice has to be changed and redeployed. Whereas search, streaming video, there is no change. Only this video recommendation has to be deployed. So here you can see that each of the microservices has a different version. Search will be in version 1.0, the streaming video version 2.1, video recommendation version 2.1. So the rule is it is not mandatory that each of the microservice should be in the same version. So this architecture we can relate to a fine restaurant, wherein what are the different services that we see in a restaurant? There will be one reception service, right? After that, cooking service is there, then delivery, okay. Payment, that is in the reception service. Seating arrangement, exactly. So if we look at the process which is involved here, each of the process is independent, right? So there may not be that much dependency when compared to that tea shop wherein one single instance is performing all the operations. So here, there is a reception service. That person will take us to the corresponding location where we want to sit. And the person will come and receive the order. And that order will be transferred to the cooking department. So they will keep on, what is their responsibility? They will keep on cooking based on the customer choice, right? So each of the these areas, so each of the modules are not that much interconnected. Now let's see how this microservices communicate. They communicate with help of API. If video recommendation microservice needs some data which is available inside streaming microservice. So the data will be available inside the database, right? So here, if one microservice want to access the data from another microservice, it cannot directly access the database of another microservice. Rather, it will be taking help of APIs. So the video recommendation microservice will call the API of streaming microservice. To that request from video recommendation microservice, the streaming microservice will provide a response. And inside that response, the required information will be there. So it is the responsibility of streaming microservice to take the data based on the request. So the microservices communicate via APIs, and each of the API or each of the microservice has a health endpoint. So the purpose of health endpoint check is to ensure the status of each of the microservice, whether it is up and running, what is the database connectivity status, the CPU usage, the memory usage, all will be tracked with help of this health endpoint of each of the microservice. So whenever you are doing an automation testing or whenever you want to do a sanity testing, include the health endpoint check as the first candidate. If microservice itself is not working, you don't need to execute your entire regression suite. So the health endpoint check has to be considered as the first item in any of the sanity suite. Now let's see what are the advantages of this architecture. First one is scalability. So here, each of the microservice, based on the number of requests, it will create multiple instances. It can create multiple instances. In this example, let's say in evening 7 p.m. to 10 p.m., in streaming video microservice, there is a high request or there is a, the load is high. At that time, search and video recommend compared to search and video recommendation, the traffic in streaming videos is high. That time, that microservice can be scaled. Multiple instances can be created for the streaming video microservice based on the load. And once the usage or once the request comes down, that instance can be killed. So that is scalability. What do you mean by reliability? Application will be available. Or we can say that we can trust the application. Here, there are 3 microservices. And if any of the microservice is down, the other microservices are still functioning. If video recommendation is not working properly, it does not mean that the entire Netflix application is down. You can still use search functionality or you can use streaming video functionality. Only this video recommendation capability is affected. So when you are doing testing, that is not a block state. Even if one microservice is not available, you can perform testing in any other area based on the availability of the services. This microservice architecture, it promotes agility. What do you mean by agility? We can say like smaller teams working together and delivering frequently. So this architecture promotes agile way of working, and each of the microservice has its own business logic. So they have the right to choose their own programming language. It is not mandatory that every microservice has to be written in the same programming language. Based on the developer's choice, they can develop the microservice. So teams can experiment with new features and rollback if something doesn't work. And it supports continuous development and it supports agility also. So these are some of the disadvantages of microservice architecture. What about the infrastructure cost? When new microservices are added, what about the infrastructure cost? It will be high, right? So there is some infrastructure cost involved in the deployment procedure, hosting infrastructure and all. So cost will be on a higher side. And when in the development phase, the developers want to test the application locally, there will be some difficulty. They have to write some mock services to simulate different microservices, and then only they will be able to do the testing locally. The next one is containerization and microservices. So what is a container? What's the simple meaning of container? Is this a container? Yeah, this is a container, right? So this container in microservice architecture, It is used to manage individual microservices independently. There are different microservices. You can deploy one microservice in one container. So here we have two containers, one for video recommendation and another one for search. And the containers are created with help of containerization platform like Docker. Multiple containers can be created. As much as possible, this architecture is trying to reduce the dependency between different microservices. So this containerization, it will provide an isolated environment for each of the microservices to run. And when it comes to scalability, using this containerization approach, the different individual microservices are scaled up. Then it simplifies development, testing, and deployment activities. Now we'll see what are the different approaches we can use in microservices testing. First one is shift left testing. What does that mean? Shift left. What does that mean? In an application development, what does shift left mean? We are moving ahead, right? In the early stages of development cycle, we can start testing activities. So the different testing activities that we can consider under the shift left testing is unit testing, component testing, and contract testing. So you all know about unit testing. What is unit testing? Each of the individual functions or methods that are written inside the microservices are tested. That is unit testing. In component testing, each of the microservice is tested independently. We will take that are available within that microservice that we will be testing. And if that microservice has some dependency with any other microservice, with help of Docker, with the help of stub and driver, we can simulate that activity. You know about stub and driver, right? They will provide a single input to the calling service. So that we can create mock services and we can simulate the testing wherein one microservice is integrating with another microservice. Another one is contract test. So when an API is developed, whether it is get, post, put, or delete, it has its own structure. There is a request format, and when a request is received, how it should provide the response. So it is already defined when that API is defined. So in contract testing, we are performing the API level testing. What is the request? And to that request, what is the response that we are getting? If we are giving some invalid data, or if we are giving some invalid combination, the API should give the proper response. So that type of testing we are performing in contract test. So this is an example of a e-commerce application wherein we have product service and cart service. So in product service, the unit testing can be adding product, then updating the product details, deleting the product detail, retrieving the product information. All those will come under unit testing. In component testing, what is component testing? Each of the individual microservices we will test. We will test all the functionalities that are coming under each of the microservice. If there are some dependency with any other microservice, with help of what? With the help of mock service, we can perform the testing. So here, in this example, assume that when an item is added to cart, we go to cart and we can see the item details. So the item details or the product details, it is coming from another microservice. So when we are performing a component test on cart service, we will perform the testing of cart service as it is, plus we will test the integration with the product service, where we need to check whether the data is getting properly displayed in the service or not. Then contract testing, corresponding to each of the requests which is sent, we have to verify the request time, the response time, all those we can test. Next one is end-to-end testing. This is similar to system testing. You all know what is system testing. All the business capabilities, end-to-end business capabilities are tested. This ensures that all the microservices work together. When all the microservices work together, actually we are addressing a business problem. So we can easily ensure that that particular business problem is solved. Next one is chaos testing. This is used in reliability testing. Here we are intentionally creating some failures. We will in the middle of an action or in the middle of an activity, we will kill some services. That is service failure rejection. So in service failure rejection, during the middle of an activity, we will kill that service and we will kill that service and verify how the system behaves, whether the complete system is crashing or not, or whether it gracefully exits. So all those type of testing we will perform in service failure rejection. Similarly, network partitioning. Here we are focusing on the communication. When communication between two microservices are happening, we can slow down the network speed and all. At that time, how the system behaves. So that type of testing will be performed in network partitioning. And the next one is high traffic load. So we will, in the middle of a user activity, we will suddenly increase the load. When load is suddenly increased, this comes under performance testing. We will measure the normal parameters like what is the response time, throughput, resource utilization, or we can verify. Next one is third-party dependency failure. If your application is taking help of another third-party services, let's say the payment gateways. In e-commerce application, payment gateway is a third-party dependency. So during the middle of a payment transaction, we can kill that microservice. So at that time, this should not create any unintentional result to the customer. So if there is any other alternative payment method, it has to switch back to that. The total failure is not expected in any of these cases. And there are, please note that this comes under reliability testing. And there are certain tools available for chaos testing. This chaos testing is normally done by the DevOps engineer. We need help from the DevOps engineer to perform this chaos testing. We can provide the input or we can help them to identify the scenarios. Normally, this testing can be done with the help of a DevOps team. So these are the certain tools that are available for chaos testing. One is Chaos Monkey. It is developed by Netflix. It is one of the popular chaos engineering tool. So here, it will terminate the VM where the microservice is installed. So when that VM goes down, we need to check how the system performance is. So that will be performed with help of Chaos Monkey. And Kumba is a tool that is used in the testing of containers. Here we can introduce various disruptions such as network delay and container termination during the middle of an activity, and we need to verify the behavior. These are some of the best practices in microservice testing. As I mentioned earlier, testing the microservice is a challenging task. So first the first one that come into our hand is API. So you need to automate the APIs. There are so many ways in which we can automate the API with the help of Rest Assured. We can integrate Rest Assured with BDD given when then format, and you can automate APIs. So that should be the first thing. You can automate APIs, and you have to create different test suites. One for API testing, another one for sanity testing, and another one for regression testing. So in this sanity testing, what could be the first candidate? When we are doing a microservices testing, in sanity testing, what could be the first candidate? Health endpoint check, right? Health endpoint check should be the first candidate that comes under API testing. And once you automate all the test cases, you have to integrate it to CI/CD pipeline, which will provide you the faster feedback. Yeah, so that's it from my end. Thank you.